We're recording now.
Okay, welcome everybody. This is our last session for training for this fall. We've had two previous sessions. We expect to have the links up momentarily. I think we've gone through all the hoops at YouTube to get them up on the web, so we'll be taking up. Tonight we've got basically two sessions. We've got one on programming and the people that have been involved in the beta programming, so testing out new software and hardware, and it's actually going to be pretty cool because I think most of you by now have heard about the Kinect box, so we'll get a demonstration of that. And then we also have two of our chief inspectors from the regionals to talk about inspection and how to get through inspection. So this is going to be real important for new teams and what they've got to look out for and some of the things that we're seeing at the events. One of the things I'd like to stress that we've run into problems the past few years is teams coming to the events expecting to finish their robots on Thursday at the event. And we don't want to have that happen this year. It causes all sorts of havoc to everybody if you don't come with a robot that's ready to start doing practice rounds and going for inspection. So I'm going to plead with you, make sure that your robot's finished before you get to the event. With that, I'm going to kick it off with Alex O'Neill, Team 1816, and they're going to talk about C++ and the work they've done in that beta program and a little bit about why you might want to use C++ to program your robot. Alex.
Thanks, Mark. So I'm Alex. I'm from 1816 Dream Machine, and we are going to kick off beta testing. So we did C++ for beta testing, and I guess one reason you want to pick C++ is there's a high probability that you're going to find mentors for it. It's a very well-known language. A lot of people use it for industry and computer programming, and it's pretty fast, and it compiles it better than Java, and if you're good at text-based programming, this is a good place to go to. So without further ado, I'll get started.
Click the arrow. Sorry. That down should be it.
Hover over the bottom.
Yeah.
Okay. So there is a new imaging tool this year. It's updated from last year's where it shows the image of the CBO, and it recognizes what modules you have in there. So I guess you don't have to look at the actual CBO anymore. And then also a big change are these virtual diff switches rather than on the CBO itself. You just change them from the program itself. And that's about it. Change the CBO is from 4 slots to 8, or from 8 slots to 4 slots, so it's a lot smaller. So you have more space to run for other things. Okay, another big change this year is in the Wind River itself. In the connection properties, when you go into the VxWorks option near the bottom of the screen in C++, this new window pops up with two new areas. First the processor and then the image file, the kernel image file. The processor, you may need to specify the processor depending upon the CBO you use. That's just a new thing. And then finally the kernel. So there are two different kernels. The first one is for the old CBO and the second one is for the new CBO. You have to choose the right one for the CBO to work properly, and you have to choose that from the drop-down menu with the browse option. I was saying earlier, these are the two new kernels. The second one, the 2 is for the 4 slot, and the first one there is for the 8 slot. Okay, another big programming change is the module numbers when you're programming. So now you don't need to specify module numbers, you only need to specify the module order. So if you have 2 modules of the same type plugged into the CBO, instead of just saying the first, what the slot is for the module, you say what order comes in first. And so if you have a second one, then the second one you plugged in is going to be specified by the number 2 there. So it is regardless of the slot number, and so you can just fill up sequentially on the CBO. Also, a big change this year is command-based programming. So There's a new system of subsystem and commands. It's mainly used for splitting up tasks when you're programming. So, for instance, last year on autonomous, you could have the robot drive forward and then lift up the arm. But with command-based programming, you can have it do it at the same time by using commands. Now, there are two parts to this programming style. There's the subsystem and commands. The subsystems hold kind of the information on what each command will actually actuate on the robot, so like an arm or a piston or some wheel or something. And the commands are the actual commands that involve the subsystems, which then tell the robot what to do. Another thing with the command-based programming are now headers, which essentially state what your commands are, and then in your C++ files you say what those different commands actually do. So that's something else that's different. There's a new driver station this year. It does not have a stop button, and this is important because they changed the stop button to spacebar, which last year was toggling from enable to disable. And so you're going to make sure that you remember that and that you don't accidentally stop the robot where you're trying to disable it. Also, they've added some stuff with the Kinect, and yeah, they've added fancy images, which I like. And the camera. So last year when they introduced the bridge, they still didn't have the camera operating from the bridge. This year they've made it so that it will operate from the bridge perfectly. If you do have the old CRIO, however, you can use the second port on the CRIO to operate the camera from. But ideally, you just want to plug it into the bridge so that, because the new CRIO only has one output. And then you're also going to want to instantiate the IP address of the camera. If it's from the old CRIO, you can do this, which is from the second port. But if it's on the new CRIO, you're going to do this to the bridge. What this also means, though, is that there's now another assigned IP for the camera. So you're not going to want to be using 10. Whatever your team number is, 11, because that's already used for the camera. And finally, I have just questions and answers. So if you have any questions, I will answer them.
How was the processing flow? Skinny leg in there if you're doing multiple command sequences at the same time?
From what I experienced, I don't think there was much lag, but I think Mr. Waldo, do you have any input?
We actually didn't get very far with the command-based programming. There was supposed to be, as far as I could tell, some wizards and other support for making it easier to get a project with command-based programming started, but they didn't have that ready in time for us to use it. So we fumbled a little bit with manually creating it, but just didn't get very far with it. So don't really have a good answer for that.
So with those command-based programming options, is that essentially just a method of implementing parallel while loops?
I guess you could look at it like that. I mean, it allows you to do two commands at the same time. So I guess it could be something like that.
Yeah, for folks who know LabVIEW, it's not even necessary to think about it because it's natural in LabVIEW. You just put two different tasks in the same box and it just works. In Java or C++, it's not quite that easy. It takes some fancy interaction to keep track of what the two tasks are doing. So this is supposed to make it easier.
Did you use the camera through the serial last year?
We did initially, but then we switched over to the bridge. So it was a bit faster.
We did the same thing. We noticed less lag
Yeah.
and less jagginess in the videos. So.
Well, last year it required a change to your driver station. We had a LabVIEW program and do it. This year it'll come to package.
Or you just have the internet browser.
Yeah.
Okay. Good. Good to hear.
Right.